Hi, this is an example problem from chapter 20. We previously solved in an instructor video this same problem using equivalent resistance. I'm going to show you how to use the Kirchhoff's rules to do this as well. We've already reviewed the loop rule. We're going to see that here we're going to apply both the loop rules and the junction rule. And by doing that, we're going to get a set of equations that will allow us to solve for the current through all of the resistors. And we know that if we know the current through all the resistors and the resistance of them all, then we can use Ohm's law to calculate the voltage across them all. We can use the power equation to calculate the power. We can do everything we did previously. So let's see how it's done here. I'm going to start with drawing the currents. The first thing you need to do when you're going to do Kirchhoff's rules. So I'm going to go ahead and use three different colors just to see. So we've got a couple junctions in this circuit. Let me go ahead and just highlight those junctions. Here's one here. And there's another one right here. So we got two junctions. All right, so we're going to have some different currents in the different parts of this circuit. So let me go ahead and do from this bottom junction here. In that entire wire, there's a single circuit, and I'm going to call this one I1 to give it a name. Now, when we get to this junction at the top, the current splits. I'm going to make one branch go down here, and I'm going to give this one a name I2. And finally, at the top junction, we have another split here, so this current's going to come around this direction, and I've got it going in that direction. I'm going to give it a name I3. Now, I chose the directions of those currents. It's free, up to me to pick. I picked the right directions because I can see the way the battery is going to cause it to flow. But if I was wrong, again, I'm going to just get negative signs for the currents. If you choose wrong, don't worry about it. Just go through, finish the problem. If you get a negative value for your current, then you just have to reverse the sign in the picture. That's all. All right, so first thing we're going to do is apply the junction rule. We've got two junctions, and I'm just going to pick one because since they both contain the three currents, blue, purple, green, as you can see, it's going to give me the same set of equations. So let me just pick the bottom one real quick. And let's recall what the junction rule says. It says that if you look at a junction, charge is conserved. So charges are flowing in the current, and when they come to a junction, they got to go one way or the other. If whatever comes into the current, the sum has got to be equal to whatever flows out. There's no charges lost, in other words. So focusing on this junction here, we'll go ahead and apply the junction rule. And so which are the currents that flow in? Look at the green one goes in, the purple one goes in. So I'm going to say the sum of I in equals the sum of I out. And again, we said flowing into that point are I2 and I3. So let's add those together. And flowing out, there it is, I1. We've got three variables. I'm going to need three equations to solve for them. The next two equations we're going to use Kirchhoff's loop rule. So let me go ahead to set this up. I'm going to do two different loops. As I said, I need three equations. And let me go ahead and just label some points here. So let me call this one A, call this one B, C, D, E, and F. That's just to simplify things a little bit. So let's go ahead and do the loop rules. And the first one I'm going to do is I'm going to do A, B, C, D, A. In other words, I'm going to circle around in this direction. And I need to go ahead and put the plus and minus signs on the resistors. So for the resistors, let's look at the one in the middle with the green. It flows from high to low. So I'm following the current. For the other one there with the purple, we've got a couple resistors there, right? High to low. And for this one again, high to low. And there we go. We've got them all. So high to low in the direction of the current. Let's do A, B, C, D, A. So as I start to traverse this circuit here, I'm kind of just going along. All right, I'm going to go through here, nothing happened here. Oop, I'm going to jump this guy, right? So I've got a voltage plus 3, because I went from low to high. Keep on going here. All right, we're moving along, nothing going on, nothing going on. Oh, I got to jump this guy. That's a decrease. We go from high to low, and we're going to use Ohm's law to write the voltage there. Remember, V equals IR. In this case, we've got I2 times 18 ohms. And remember that this was a drop. We went from high to low, and so decrease, I got to put a minus sign there. And if we think about continuing on, okay, we've gotten back to point A and we are done with that loop. So we've returned to where the starting point is, and so we add these equal to 0. And we can keep on going here. We need one more loop. So let's go ahead and we're going to do, let's do the loop A, D, E, F, back to A again. So I'm going to start at point A and I'm going to go clockwise. So I'm going to start here. Got to jump this resistor. We go from low to high. That's going to be positive. So we've got a plus. V equals IR. This is I2 times 18 ohms, R, plus, going to continue on here. We're going to go down here, a decrease. This is negative I3 times 22 ohms. Plus, as we go along here, we come to another resistor, got to go down again. Be a negative I3, it's the purple one again, times 14 ohms, and we are back to A. So this is all equal to 0. All right, let's clean up our 3 equations with our 3 unknowns. So we've got the first one here. The second equation, if we just clean that up a little bit, that's going to be plus 3, should have put a volts here, minus 18 ohms times I2 equals 0. That's this one. Got that one already. And the last one, let me just clean it up real quick. So we've got these 3. And we're trying to solve for the 3 values of I. At this point, it's just a bunch of algebra. I'm not going to do the entire thing here, but I will go ahead and show that with the easy one, equation 2, we can go ahead and immediately solve for I2, and we'll just check and verify that it is the same as before when we solve this problem. So looking at this, we're going to have minus 18 ohms times I2 is equal to a negative 3 volts, right? We're going to divide by minus 18 ohms on both sides to come up with our answer. And we get 0.167 amps. That's the same answer as we got previously. So we now know what I2 is equal to. We picked the right direction because it's positive. And of course, now we're going to have to go and plug I2 into these two equations and work with those two equations to solve for the remaining unknowns. So I'm not going to do that part right now, but it's just a matter of algebra. And so you can see these problems, they can be done more than one way. Either way that you choose is somewhat lengthy. You can do the equivalent resistance method, or you can use Kirchhoff's rules. Now in general, Kirchhoff's rules are more, they have broader applications, because there's instances where the equivalent resistance won't work, but Kirchhoff's rules will always allow you to solve a problem.